this opportunity to be once again as our Secretariat. We want to pray your presence and direction to give us insight and knowledge into the subject, and so that by the finish we will have gained more knowledge in the energy sector to go and work more effectively to your glory. In Jesus' name. Amen. Amen. All right. Thank you very much, ladies and gentlemen, for being with us this evening. It is an honor to have you here with us, and for our guest online. When we check, we have about 80 people online. It shows that most of our people who's coming find it difficult joining us in person. We hope to find ways to improve those who are attending in person. We're still expecting some people to come, but we do not want to waste any further time. This evening, we are pleased to have to bear the function for us our own senior engineer, Engineer Bernard Modi, a very distinguished engineer indeed with many years of practice in the sector. More so, he is on retirement, but he never fails to respond to our invitations when we call him to come and support us. And he always readily joins us in all our functions. So we are very grateful, sir, for being with us this evening. So without much ado, I would want to invite him to come and give us an introduction of our guest speaker for the evening. All right. Thank you very much.
Thank you very much, Atu, for your kind words. So before I introduce the speaker, let me say that it's an honor and a privilege to be asked to chair this function for two main reasons. First, I know the capability of the speaker, and I'm happy that we have a seasoned practitioner, he knows both the theory and the practice. He's practicing and he's also teaching the theory about it, so we are in good hands. The second reason is that what we are discussing today is very topical. Everybody is concerned about the security of power supply, and everybody wishes that they can be assured of reliability of supply. So for these two reasons, I think this evening is going to be very interesting. We are behind time, so I'll go straight to talk a little bit about the speaker, who is Dr. Chris Mensah-Bonsu. He's the Chief Executive Officer of NB Energy Consulting Incorporated, a registered energy consulting company in California, US. He is also an adjunct professor of electrical engineering at California State University, and he served as a mentor to the US Energy Policy Institute. Dr. Mensah-Bonsu is a seasoned electric power industry executive consultant, practitioner, and an electrical engineering educator with over 25 years of experience in power grid planning, real-time system operations, regulatory energy policy, renewable energy, utility restructuring, and deregulated wholesale electricity markets development. Among his current responsibilities, Dr. Mensah-Bonsu advises the U.S. Department of Energy, DOE, Western Area Power Administration, on power grid planning, real-time power operations, renewable energy integration, U.S. Western transmission, interconnection, system reliability, compliance audits. If I want to continue, I'll go on and on. So let me move to the last paragraph. that says that he's previously worked 17 years for California Independent System Operator, which manages most of California's electric power grid and operates its wholesale electricity market. Dr. Mensah-Bonsu has served as energy consultant for Solar Frontier, the World Bank, ECOWAS, West African Power Pool, Deloitte Consulting, USAID, West African Energy Program, and Ghana Grid Company. Dr. Mensah-Bonsu is a senior member of the Institute of Electrical and Electronic Engineers and a professional member of the Ghana Institution of Engineering. He received the Doctor of Philosophy Ph.D. degree in Electrical Engineering from Arizona State University in year 2000. Professor Mensah-Bonsu has co-authored several peer-reviewed industry journal publications in electric power engineering. Professor Mensah-Bonsu is a celebrated and honored Ph.D. Marty who for his dedication and contribution to the field of engineering. Please, let's give him a round of applause. Before he starts his presentation, I want to welcome the online participants in particular with a special appeal. Please switch off your microphone and also possibly your video. When your video is on, it becomes a distraction. So please keep both your mic and your video off so that we can focus on what is being said. So with that, I want to hand over to the presenter. Thank you.
Thank you very much, Engineer Model. Pleasure to be here, and thank you for the kind words. We have the clicker, or we're gonna run it. Is it working this side? Okay. So, as you just heard, my name is Chris Mensah-Bonsu. To start, I would like to make this disclaimer. Say any errors and omissions in this presentation are the sole responsibility of myself. I don't proclaim to see or know everything. This is a system that I haven't worked in detail. So when I'm trying to, with little knowledge that I have about it, I'm trying to prescribe something that we can all talk about. I would like this interaction to be informal as it is, and welcome anybody who has a different opinion or suggestion so that there will be a lesson point for myself. Ghana, as you know, has been going through a lot, the energy sector, in particular, electricity, which is also interlinked with the fuel and pipelines and pricing and all that. The problems or the concerns of the system can be captured in the problem statement here. That Ghana's electric power system and energy delivery infrastructure have been plagued for many years consistently with persistent and widespread power outages and load shedding, which in some cases occur multiple times in a day and last for hours or even days on end. The electric power blackouts, which in the local language called doomsor, continue unabatedly to frustrate residential and commercial customers, business, economy, and the government. These are due in part to several factors, and some of the problems are self-inflicted, I believe, and preventable, while others are part of normal business but could benefit from better policies, planning, maintenance, and system operations management. The resulting interruptions to business, commercial activities, livelihood, and financial losses are enormous and immeasurable. This presentation is seeking an honest dialogue about our energy sector, again, our energy sector, and how best to holistically address the many problems that are so evident to many of us, while commending the industry practitioners and policymakers for their stellar work so far amidst the available limited resources. If you look at the statement here, tries to capture what we have been seeing for many years, and I believe it captures. You don't need any explanation. My mom in the village at Ajamesu sees all this. Power outages, doom sorrow many times in a day, or even days on end. The clicker is not working. So at the end of this presentation, I know for sure some of us online or even they are not power engineers or engineers themselves. So at the end of this presentation, my goal is to identify problems in each of the electricity subsystems, recommend holistic solutions to achieve a safe, reliable, secure, and resilient electricity system. But to do this, we need to understand the various components of the electric system. Then we recommend avenues for private sector participation and funding, because this electricity system is a very expensive infrastructure, and not any government can have all the money in the world to do it. Even in California, we struggle with having funds to get to where we are. What has helped us a lot is the private sector participation, generation, transmission, and things like that. Got a laser here? So where is the laser? The laser or moving forward? Yes, the laser. No. Sure, I'm still learning how to point the clicker. It doesn't show up. Okay, the clicker is not working. So
Use the mouse. Use the mouse.
the mouse.
It's output.
Okay. So I'm going to describe this in the verbally. So on the left-hand side of the screen here, you see the structure of the mouse. You are using it. Okay. So the left-hand side, this is the basic structure of the electric system. And it has the three components that I talked about. The generation side, which is the far left with those towers, right? You see like a nuclear power plant, and it has generating stations over there. And that energy gets transformed to higher voltages on that little thing sitting there with the two boxes, not the transformer, not the lines. Yes, and that is your transformer. We call it generator step-up transformer, because the generators are at the low voltage levels, maybe 20 kilovolts, and then we step it up to the transmission level. In this case, 765 kV, 500, these are not voltages that we operate here in Ghana. But as you can see, this was taken from one of the California or US blackouts, August 14, 2003. And that is the source of that picture. Once you step up, so that's the generation stations or generating subsystem on your left-hand side. You step up to the next level is a transmission system. And then if you go past the transmission system with the towers that we all see along the roads and doors and roads sides, we get into another substation, which is a step-down transformer. So after we step down the power or voltage, then now we can make use of the electricity coming into our homes. We call them end users or the electricity customers, electric customers. Now the customers also are grouped into different categories. We have industry, we have industrial load, commercial load, and then we also have residential loads. Now, most of us are put onto the residential load levels. In Ghana, we have two main categories here. We have the Ghana Grid Company, which is a high voltage transmission system, operating at 69, 161, 225, 330 kVs, including tie lines to the three neighboring countries. On the distribution side, we mainly have ECG and NETCO. I think Enclave Power is also there. Yeah. And they all operate on what we call medium voltages and low voltages. So this is to get you to understand that the electricity system is not just a Kosombo or fuel shortage or generation is not there. It's more than that. And it's important to understand we have the generation, transmission, and the distribution system. Thank you. Move to the next. So let's take a quick look at the generation station. As I said before, to be able to understand the problems, we need to also and come up with solutions. We need to understand what these systems are and what are the shortfalls in these systems. It is only after understanding the problems there that you could come up with the solutions. So the Ghana generation load as we speak, and please correct me if I'm wrong, it's 5740 or 5,740 megawatt installed generation capacity. So you saw the generation subsystem. So the generation that we get from all the generators in Ghana, we got 5740. The load, we are expecting to see 4,300, around 4,300 peak load. Peak load. This means it's not always that you hit. It's not always that you hit the 4,300, but there are certain times of the year that the load is peaking because of several reasons. But you need to make sure that you build your system to meet the peak when it occurs. If you look at last year, the peak occurred in March, and it was 4,000, just above 4,000. But as you look back, 2014, right? You see the load was only 1970. I'm going to leave all the decimals. So within 10 years, look at what our load has grown. More than twice, right? But the load is also scattered around the whole country, right? The load is scattered around the whole country. And if you look on the left-hand side, this is how the load actually behaves, or the signature of the load is such that if you look on the horizontal line, on the horizontal axis, you have the hours of the day, 24 hours, 1, 2, 3, 4, 5, up to 24. And the system operators are busy whilst we are sleeping, making sure that every hour, every minute, every second, we have enough generation to serve the load. The loads are the curves up there. You have a thick black one, if you can see black with a little green in it. Okay. And then the time of day, and this side, which is the load or demand projection. Looking at it carefully, you see between 6 to 7, all of a sudden, the load sharply increases. And then between 7 and 9, it attains a peak. And then after 9 o'clock, 9 p.m., typically it drops down gradually. And then the same thing repeats the next day. Okay. And why is it important to know this? Because we need to be, so, just, please get me a new, it's not gonna help us, if you can, please. So of those who drove all the way here, this is what you get, right? You get a better, I show this for a reason because it causes problem for us. And we need to identify measures or mitigation to address this area, that sharp peak. And so pay attention to that. I'll come back to the solutions. And also look at the generation 5740. The generation has characteristics. So let's go to the next page, please. Now let's get a little deeper into the generation. Of the 5740 installed capacity, we have 60%, 60.5% being generated by independent power producers. Okay. And this is about 3,400 megawatts from 11 aggregated generators, Asogli, all those other generators, Home, Jensen, SunPower, all that. And then the government one is about 39.5. This includes the Kosombo, the Pong, hydros, and also the Pong thermal plant, thermal, and all that. The key problem that we have here is that most of these generation that we have, they are predominantly dependent on natural gas, all of them, except for the hydros that I mentioned. They are all, majority of them is on natural gas. And you look at them, where are all the generation located? They are located on the southern part of Ghana. First, they are fuel biased, right? You think natural gas is the only fuel source for power plants. No, but they are also all that. Let's get a new one. Oh, yeah. Simple contract. Simple. Later, red flag. And you gotta find that. Yeah. And it has a laser thing. Yes, for the back.
You know, so
Very good. Not laser. So I mentioned the generation pockets, right? They are all in the south. I mentioned Akosombo, right, where the dam is. Pond is not that far away from Akosombo. And then where's the next one? Tema, somewhere here. And then Takoradi, the Tiabo areas have that. This is where these three pockets are where most of the generation are. We do have, recently we have Maso thermal plant, the 250 megawatts, formerly Ameri, has been moved here. And then over here we have the wind power, which is hydro. But the rest is all here. And I did mention that generation is scattered around the whole country. That means to serve the load in these areas, you have to build transmission lines to get to them. These transmission lines are not cheap, very, very, very expensive. And if we continue to say, we're always gonna arrange for fuel to power these, and we are powering just natural gas or like crude oil or diesel, now you see where our problems are. A large part of the country remains generation desert. Talk about interconnections too. To the Ivory Coast, to Togo, Benin, and the transmission lines going. So we take power, we transfer power all the way there, all the way this way and that way. So now you can see that we have inherent problems in our electricity system. So the solution is not just buying fuel, can get fuel from somewhere in Nigeria and all that. But structurally, we have problems. And not until these problems are resolved, I think every government, no matter who you are, you're gonna still have these problems. And you end up going to the market to purchase expensive fuel, natural gas to support us. So the first structural problem is the location of all the generation, majority of them in the south. The fuel is biased towards natural gas, whilst we have other generation fuel that we can use and abundant in this country. Okay, God-given. We're good there. We also look at the load profile. We look at the load profile, and it has a signature that every system operator, I used to work as an operator, when you get into the peak, at times we say, get ahead of the load. And you need resources to do that. And when your fuel is tied to natural gas only, without any room for movement for other sources, and then you have scarcity of natural gas, no matter amount of money to save you, right? And we've seen it happening here. And because of that, this is causing runaway electricity bills and routine rate escalations to try to pay back the fuel and other things, operating costs. Everything goes up. Now, we also have take-or-pay contract that also has a kick in our butt. But I'm not going to get into the details of all of that because I understand there has been renegotiations and other things being done to them. However, post-contracts, what do we do? Do we do a better job validating, making sure when we need the generators to be there, they will be available, or they are available when we need them? So performance monitoring, inspection, and if we call them and they don't produce, are there any penalties or remedies out there to make sure they deliver by the contract? Because the take-or-pay contracts are mostly capacity contracts. So it's an insurance for the operator and the government to say, I'm paying you this, so when I need you, you have to be there. And if you call them and they don't respond, are you very certain that they are not available? I don't know. I would like to hear from you, the practitioners here, if it's okay to talk about it. As I said before in the disclaimer, I'm just trying to learn, okay? I point these out. The other thing is heat rate curves for generators, right? And the same thing, we need to validate them to make sure, especially from the Energy Commission, who gives the licenses for power plants, before any power plant goes in for application or be built. From my experience, they'll have to declare their production capability, and that is in the form of heat rate curves. We do production simulations to see if indeed they are capable of what they say they are. Lower heat rate curves means more efficient. So you have two units, one has a higher heat rate curve, one has a lower one. It serves me right to go with a lower heat rate curve one. And why is that important? Because it has direct relationship with economic dispatch, right? That's where you differentiate the heat rate curves, MBTU versus power, then you get your incremental cost, dollar per megawatt hour versus power. And that's how you dispatch the generators. And so it has direct cost and adequacy implication that needs to be managed, monitored, inspected, and occasionally dealt with. I'm not sure, and I don't know, and I'm ready to learn how often do we check on these things. So I've pointed about two main things, which is structurally restricting almost all the existing power plant, almost all, to a very limited part of the country, the three generation pockets, Akosombo, Tema, and Takoradi. And the second condition, biased power plant fuel, which is natural gas mostly. And also, this natural gas is inelastically dependent on import procurement. We've heard ministers after ministers saying we have to procure, we have to buy, and, we procure mostly from Nigeria, through the West Africa West African gas pipeline. So these two main conditions, fundamentally, they are all contributing factors to why we always have to so. And we try to solve it by pumping more money into it, pumping more money into it. And I'm afraid we have to look at it differently. So what can we do? And that goes to Dr. Boachi, your question. We need to find, it's clear that now we need to diversify our portfolio, generation for portfolio. And for now, we have a lot of solar and wind. Those of you who have driven around Adansege area, there's a lot of wind there that we can tap into, and it's free, right? When they are available. And then if you go beyond that, the rest of the country, nobody needs any explanation in terms of solar exposure. If you look at where I live now, in California, in places like Germany, even middle belt of US, where they don't have that much sun exposure as we have here, they are all aggressively pursuing solar and wind. And my recommendation is that we should reconsider all the money that we're pumping into the gas to make sure we are floating. We should set something aside and have a Marshall Plan for the energy sector and look seriously into renewable energy. If you do that, this is what it does for you. It will enhance reliability of the power supply. Most of us put our money in investment, right? Stocks and bonds and all that. We do that. We want to make sure we are diversified so that when the stock market crashes, at least I have my bonds sitting there, or mutual funds or something. But this is the case in Ghana, everything is put in one basket, almost.
The bond is not secure in Ghana.
Well, I'm just a general investment, smart investors. But living in Ghana doesn't mean you are restricted. There's so many markets out there. But you get my point, right? You get it. Yeah. So what are the things that this is going to help you if you have renewable energy scattered around the whole country? It helps you in so many different ways. It cuts down new transmission building, right? Because now the generators are right there closer to other parts of the country. You don't need to build transmission line or upgrade transmission lines all the way from the south to up there. We could put renewables, which is solar, northern region, to just do the export through those generators to Burkina Faso or other places that we do bilateral transfers. Now,
if we can note it down, that would be great. But if you cannot note it down, I think we can develop it.
yeah. But let me get to this point, and then we finish with the structural issues. And so what this does for you is that it will provide the needed relief for existing hydro, because the questions people come up with, well, solar, around 6-7, solar is gone. So what is the use in relation to the peak load profile that I showed you? But yeah, if you have solar, what you can do is it serves as a relief to the hydros and even the natural gas plants. When the solar is peaking, just use that so that you could, when you get a peak, solar is not there. Now you have other sources of power. So there's not all this, the strain is not all on the thermal plants, right? So in terms of poor hydro conditions, right, you could also during the day, solar is there for you, and in the night, wind. And when, of course, there is scarcity of natural gas, you have something else to rely upon. Another thing that we don't talk about here that much, which have gained traction in other parts of the world, is battery energy storage systems. And battery energy storage systems have unique application when you get to your, is it going back? Yeah. over here. Normally, system operators will tell you when you get to this point, you are struggling for energy. And with batteries, they have instant injection to the system. So this ramp, when you get to this ramp, this sharp ramp, this is a nightmare of any system operator. Those of you who have worked in system operations will tell you. Difficult to get how many load? You are looking at 3,500 somewhere. You go horizontal, this is your load. So let's say it's 3,500. And it goes past 500, 400. Oh, sorry, 4,000. And that's about 500, 600 megawatts within how many? 1 hour. Now tell me, where do you get that 600 megawatts in an hour when you are scarce in natural gas? Your fuel is not there, right? So that's where the wind and all that comes to help you. So at this point, solar won't be active, of course, but because you have rested the natural gas and preserved some of your gas fuel, now you can break it up so your fuel reserve is replenished in a way, so you can use it. Now you can take questions.
I think some of the things I came in a bit late, so I hope you wouldn't mind if I go over certain things. First of all, in the issue of IPP, unless my memory is a little bit, I saw BUI there. Where I thought, am I?
Indications are that BUI is a private, it's not a government power plant.
It's government.
Is it?
It is government.
Okay. I thought so too, but from the data I got, said
Don't
it
go
was
to that data again.
okay. But even with that, I told you that the hydros, it becomes 4 hydros, and it's not sufficient. It doesn't solve this problem either.
It isn't. And
Yeah.
the other area is this battery energy. What sort of percentage does it? If you look at the overall typical national capacity, what sort of percentage is battery energy?
Exana?
No, what this paragraph is based on is a battery energy storage system. You are a suggestion.
It's a recommendation
Yeah.
for us to consider it here as well. Because in California and other parts of the world,
Yeah.
I showed the load profile.
Yeah,
When
what
it's
if
peaking.
you take California, for instance, what percentage does the battery energy storage system in the overall capacity in California?
Oh, it's quite, you easily get about 6,000-7,000, and it keeps growing.
No, percentage of the power.
So California load, the maximum we've had was 56,000 megawatts.
And the battery
With the-
constitute what percentage?
Well, at the time, the batteries weren't there, but now we are hitting 40, and if our batteries are about 6,000, that is about, you do the math.
No.
Yeah, about 10%.
Yes.
Yeah.
And then this, where does spinning reserve have play in this?
Oh, you get it into operating reserves, come back later. Yeah, because the batteries are also certified, some of them can be certified for operating reserves, which is spinning and non-spinning reserves. Yeah, so we use that too. That is right there at the ramp, the sharp ramp.
Yeah.
We call it the spinning reserve, non-spinning. And the batteries will just come in instantly to assist. Yeah. So batteries are serving as spinning, non-spinning reserves as well.
Okay, that's the point. But are we going to get it from China or from?
Well, I know you don't mean that, but I also respect the engineers and the practitioners here that when it comes to it, they will know the best things to do for the country. I believe in that. So when it gets there, and if we have to help, we can help too. Yeah. But these are things that I've already told you about the inherent structural problems in our system.
Yeah.
And it's like a sword on your nephew. You can continue to keep powder on it or put the fire on it. But you keep powder on it, it covers it, and then perhaps it will never be solved. But I'm just recommending that we look at some of these things. And it's been done. It's not like experimental. The battery energy storage systems are all over. Right. Question, sir.
We talk of diversification.
Yes.
I mean, you know, in investment, your profile determines the kind of diversification.
That's true.
So, what's our risk profile as a nation?
Okay.
That's
yeah.
the first question. The second is that everything requires investment. You know, for example, I mean, if we had our way, we would simply use solar, which is abundant. But we also know, you know, the cost, the efficiency, you know, all these other factors come in. So what really would help is if somebody gave us kind of a matrix, which says, you know, and then we also these things are moving over time. You know, and for example, in digital signal processing, for example, Kodak is out of business today because the technology fundamentally changed. They do not invest in digital signal processing. So chemistry, which used to be keen, went away. And we know that some of these things are emerging, yet our budget is limited. So how do you reconcile the two to say, maybe at this point, we should start investing, you know, give some kind of an investment profile for the next 10 years or so. I think that would be very important. Because we tend to hear, the answer is, but the answer is not. It is much more complex. You know,
Let me help you out, Dr. Boyce. Thank you for your two questions. I think as Engineer Mode suggested, as he suggested, it'll do us a good favor if we go and finish it because I have recommendations for that. And again, in terms of solar and battery energy storage, those are not the only recommendations we have here. They are not emergent. They are part of our system today. It's not here, but it's part of our system. It's not something experimental. People are using it. It's out there. In terms of money, it's integral part of the system today.
Nobody's using 100%.
Oh, California is moving there. We already hit 50%. But let's hold that for now. Okay. So I just want to clarify that all these things are not classroom, university lab experiments.
No.
Australia, Japan, China, Southern America, US, Europe, they are moving towards that. It doesn't say that doesn't mean we should ignore or neglect our thermal plants. That's not what I'm saying. But I'm trying to say, let us expand our fuel portfolio so that we can rely on others when we don't have the others available, for instance, natural gas. Yeah. Okay.
But how you do that in an efficient, you know, cost-effective manner? I think that's.
Oh, that is why I said I trust the engineers here. Well, look, even in California, we rely on consultants to do things for us also. If the vision is there and you want to do it, there are people around the world to do it for you. Even here in Ghana, if you want to do it, you will have it. Okay. In terms of funding, I've proposed a few areas of funding for that as well. Very simple things that we can do. I know we are not a $1 trillion economy. So I have some recommendations in terms of funding, how we save cost, all of that in. I know somebody online wants to take, but maybe we should finish. Yeah. Got time?
Yes.
Yeah. So again, two things. or three things. We have natural gas, handcuff us, and then we have our generation, most of them in the south. So those, as they continue to stay, they do so, nobody will solve it. I can hopefully and can 100% say that, unless we diversify. And we can diversify using our God-given natural fuels around the country, solar, wind, to help us. In terms of money, we still buy gas. We still do long transmission lines. Set some of the money aside, make it a plan. It's okay, we're gonna continue to move, but we set money aside on this side so that certain number of years we meet a target. All the countries do that. They don't just go and drop everything and build new stuff. But instead of, I think I've made myself clear, so you can move on. Thank you. So that was solution one, right? Diversify by relying on renewables. One of the things we can take away from as a government.
Use the clip.
Use that one.
Use this one.
Oh, okay, good. So there are several ways of developing this solar and wind stuff, right? You can use some on the high voltage, what here we call the NITS, National Interconnected Transmission System, basically in the grid domain, high voltage 161, 225. You can put solar on those. In California and other parts, we put solar on 500 kV lines. One of my first projects was 550 megawatts of solar. Warren Buffett funded that. It's in operation. It's been in operation since 2016. Okay, so at the Carrizo Plains, if you Google that, you will see. This was back in 2016, right? So on the transmission side, we can build collector systems to help investors to connect into it, to feed it into the transmission system. On the distribution side too, we can have smaller generation, either rooftop, right? Generation, which is mostly solar. All of that, they add up. A little here, a little there, a little there. We shouldn't see it as you need $1 trillion, $1 billion to do this. Just little by little, before you know, you put so many of them on rooftop people's homes. And the other thing that helps you with this is that they are non-transmission or alternative non-transmission projects. I said earlier on, instead of building all your transmission line from the south to the north, what about if I have generation? That means I limit the amount of transmission I build, because the generation now is closer to the load. And that's what you want, even for operations. So non-transmission alternatives, they reduce the cost of constructing new and expensive long transmission lines, as well as enhance the overall power supply, reliability, and importantly, real-time system operations. So if you have a combination of power plants, again, not limiting any of them, solar, wind, hydro, natural gas, strategically, right, not all in the south, strategically developed and placed around the NITS, which is the high voltage areas, and the end user locations across the country, all over across the country, that will provide a robust supply capability, isn't it? And when we are scarce of, there is a scarcity of natural gas, we have solar during the day. In the night, we have wind, all right? And then even if you don't have enough gas, you can hold it off and use the other alternatives fuel. So the nutshell is save as cost. Right? What else can we do? In the short term, instead of building long pipelines like we have done for the generation, we can start gradually to construct what we call gasification depots, right, around the transmission network, such that we can transport liquefied natural gas and then gasify them into natural gas used for the power plant. That's another option to transport them and then the depots. Well, the liquefied can be transported. We don't think so?
Well, I'm just asking now. Yeah, but anyway, you will talk about that.
Yeah, so these are some of the things I'm throwing out there that others have done it and they do it still. Even in the developed countries, they still have these depots around, right? And so in the long, short term, we can do that. We're trying to find ways to get generation into different parts of the country instead of sitting, all of them sitting in the south, right? Some of them will be first priority, some be second option, but I quite believe that the solar is something we can easily do involving citizens, okay? In the long term, what you like to see is permanent pipelines feeding there, which is more expensive, right? But we can hang in with the solar in the locations and also doing the liquefied natural gas to transport, to support the grid. Structurally, we talk about take or pay contract, right? And what take or pay or power purchasing agreements, what they do for us, for the system, right? The goal of it is to improve generation adequacy. That's all the take or pay contracts do for us, that there is an insurance on these units. When we need them, they will be available. So we pay them money. It's like your auto insurance, right? You pay insurance, you don't get into an accident. But you hope that when you get one, I hope you don't get one, they will be there to take care of you, right? And that's what the take or pay capacity payment is supposed to do. Whether it was done right or wrong, this is not a discussion here. I want to make that disclaimer. Secondary goal is to improve security, generation security. Right? But what see, there's something also in for the generator. Generators, like any business, they have fixed costs. So they want to make sure that even if they are not getting any profit, their fixed costs will be recovered. And so they go in and do the contract, the capacity contracts, to at least cover something, whether they are generating or not. But what we should also know is that the take or pay cost, all of it, it gets transferred to the user. And it becomes incumbent upon us to make sure when we are doing these contracts, we consider the user, because in the end, we are the ones going to pay. It's not government. And people talk about high electricity bills. My house in Kumasi, I see the same, but I can't do anything. All of us are being impacted. High electricity bills. Every year, every month or 6 months, there are rate escalations because we need to feed this drain, the beast. And so the recommendation here is that as we are going through these things, we need to also be careful and think that it's coming back to us. Okay, that's what I would say about the take or pay. And once we have it, and I've said it before, we need to manage it, right? Level agreements. We need to manage it and see if we call them and they say they are not available, are they really playing games, sitting there and collecting and drinking Kool-Aid under the tree, just collecting their money, right? Or are they even generating and exporting it somewhere? Especially, I know in Ghana, the government also has an arrangement for fuel. So if we're doing that, it's even more important for us to know, are they really using our fuel wisely? I think it's a fair question to ask. All these little things help save us a lot of money. People don't see it that way, but I see that if you manage all these contracts well, you would save a lot of money at cost. So I think I've said all this slide is saying that we need to convince ourselves that do these generators, do they deserve the capacity payment? Right? For performance and all that, you need to make sure. Are capacity payments being paid unduly? Even when the generator is not available, it tells us it's not available, but we know there's nothing wrong with it. Who is checking? Who is inspecting? I would think the Energy Commission has, and I'm glad that my boss is here, will have a mandate to actually. California, we do that. We do spot check on the fields. If you have field team that go in and check, they'll check if you produce or didn't or whatever. We see it. Secondly, we have applications that see every generator performance, status, production level on our apps. Everybody who needs to know will sit in their office and there's this generator is on, this generator is off. You can call, why are you off? Right? Even if they want to do maintenance, they have to come for permission. Because in emergency, we have something that we call non-touch. So any plant or routine maintenance is shut down by the system operator so that generators and transmission lines and equipment will be available to serve the load. I'm sure you do something like that here. I'm not saying, I don't know, right? But if we don't do that, this is the time for us to start thinking through these things. These are all money-saving avenues for the industry. I think I said this earlier, that there is a direct correlation between the heat rates and energy production, right? And we're talking about inspection and all that. Besides this, heat rates and take-or pay, there's other component, the reserves. So what you mentioned, the spinning reserve and all that. So the reserves we call ancillary services. And those of you in the industry know ancillary services come in mainly four forms: regulation up, regulation down. For frequency control, ACE, area control, area load frequency control, or megawatt frequency control. But then you have the capacity, which is the 10-minute product. You learn it in school, but it's being used. So we call it spinning and non-spinning reserve. What it is that if I certify a generator for capacity payment spinning, it means that that unit certified to be online, and if I call it within 10 minutes, say the grid could calls that unit and says, I want you to dispatch to 20 megawatts in the next 10 minutes for 1 hour. Within 10 minutes, a spinning generator should be able to come online and deliver that 20 megawatts that is being called for, X amount of time that is being asked for. You get that, right? Non-spin, it means the generator is offline, but when I call that generator, it has a capability such that within 10 minutes, it can start synchronized and then get me my 20 megawatt, in this case, 20 megawatts that Greco wants. Within 10 minutes, it's fast. Usually they are PKs, right? It's quick. And those are key solutions for real-time operations. In fact, if you look at the load curve, where that sharp thing goes in, they help you over the peakers quickly come on. And now we're saying add batteries to support that. So what we can say here is that it's all and not just one. Okay, because they all have their capabilities, different capabilities. What is this thing here? Can you take that X log thing that is, can you take it? Oh. Yeah. I think if you look at the summary statement, the problem statement I put up front, then they should be concerned to the government and end users. This runaway electricity bills, we all suffering, but we have to. It's inelastic. You can do without it, and the routine escalations. And I'm proposing that this could be attributed to high cost of fuel, because we must have that natural gas at all costs. And all of you know, when you do contracts, in emergencies, you never do a very good contract. Because the guy, everything is published. Ghana, doomsday, they don't have power, blackout is gonna come for 1 week. Where you buy your gas, they can gouge you, as we say in California. Oh, you need it? 10 times the price. Well, okay, leave. You can leave, right? Because electricity has security implications, life-threatening matters. And then you have to go, the minister and his people at the ministry will go and buy it, right? And as you buy that, it escalates the next bills, right? So I'm thinking we have to find a way to curb that down. Our power contracts going forward, we need to be a little vigilant as we going through power contracts. I've heard the minister and the team, they are canceling some and they are renegotiating some. It's okay, it's happened, but what do we learn from it? If we don't learn from it, that is where, it's not good. But I'm sure there will be so many power contracts, fuel contracts that will be coming. But are we going to apply those knowledge and make it better for ourselves and Ghana? So what do we say here? This is very dear to my heart. And you notice that you can read it yourself, but I'm going to tell you in a nutshell. It is very important that as system operators, as practitioners, as the ministries, government institutions, Energy Commission, PURC, GRIDCO, VRA, it's important for all of us to know what every generator is doing. We have to be able to track every electron. We call movement of electrons as electricity. From generation side through the transmission side, all the way to end user. We have to account for every drop of that electricity. And by so doing, there are apps there that, in fact, we use it where I am. It's easy to develop. It's not a big thing. If you set your mind on it, you can finish it within maybe 6 months. And it'll link all the generators in your system. Here, you don't even have that many, right? And anybody who needs to know can pick their smartphone and they see this generator is up, this generator is down. Operator can see that. So there's no lying behind the scene. I'm not accusing anybody of lying, but deception or deceit. So we can track all of them in terms of the fuel. There is also a section for analysis from this kind of tool that you can look at the heat rate, look at the fuel that has been arranged for this plant, and see whether they actually use that fuel to produce equivalent energy, because we know heat rate curves has direct correlation between heat energy and electrical energy, which is power, megawatt hour. And so we can track all of that in a simple app and see how this will help us. So I think this is something, not to accuse anybody for playing games. If government wants and put this thing in 3 months to 6 months, the evidence will be there for everybody. I don't need to say it. Because in California, we used to go inspect them, and they were even there with all the laws and remedies. We don't use penalties, they say remedy, whatever is going on. They were still playing that. Okay, they were just not producing and creating scarcity, so real-time price will shoot. because we have electricity markets there. And some were sanctioned. Some of them who had operating reserve contracts were taken away from them. A new generation came and displaced them. If you don't play safe, you'll be in business. So those of you who have, I think they have the presentations online here. Keep those. And let's see if this country is ready for transparency, right? Yeah, we have to. So having done the generation system, the key things to take away from here is that inherently we have a problem. So if anybody tells you, I've solved this, I'm going to solve this, all that, you ask them those three questions. Do we have generation outside the three pockets, exception of Amomaso and Bui, right? And where are they? If it's not, just not. Secondly, our fuel source, how diverse is it? Not, because we're gonna go buy expensive natural gas just to make sure we save faces. Look at that. The load profile, right? How are we meeting that? Do we meet it reliably? And if there is a shortage of natural gas, we solve them. So are we going to be okay? So those are the questions you ask yourself on the generation side. Transmission system, I already talked about gridco, and I'm not going to get into what a transmission line and all that stuff. But just to say, the transmission system is what transfers the power from the generation side all the way to the distribution side to feed the customer. Gridco is primarily in this domain, the only entity. And Gridco has two main functions, so many, but two main of them. First one is grid planning, meaning they perform studies, identify problems, current problems, and future problems, and make recommendations for solutions in terms of projects. Projects can be capital projects, can be operating procedures, special protection schemes. When a line gets to this point, trip this generator or trip this load, that kind of stuff. But mostly you want to reinforce the system with capital projects. Maybe build a new transmission, or in this case, build the collector systems so that investors can come in and connect their generation on the high voltage side. They also have the real-time system as their function, and they are the real-time system operator. I can see some of the old system operators there, manager, Linda. So what they do in simple terms is that Gridco is always up there, second by second, balancing the load. Our load is not staircase, right? It's smooth and it's time varying load change. So you go home and you switch on your light, you don't ask permission from Gridco. And you go and you turn it off, you don't. So load is always second by second is moving. And I call it just in time, on demand balancing. And that's what Gridco does. It's a very difficult job. I did that for a number of years. But if the planning is right and the projects are implemented, it makes it easier for the operator. So Gridco perform the studies, identify problems. Hopefully, they present those recommendations for mitigation and it gets implemented. And that is how you strengthen your power system for the longer term. But if you find problems and you don't do anything about it, obviously, that's a different story, right? But two things, system operator, balancing load and generation. And that's where the operating reserves also come in to support the system operations. The main goal of the transmission operator or the system is to achieve a safer, you want to operate that grid safely, right? Don't bend, people don't die when they touch it and stuff. You touch it, you die. Reliable, it has to be secure. When we say something is reliable, is such that it's not different from economics or manufacturing. It's reliable because when you need it, it will be there, and the quality is good. And it's secure because in terms of transmission, you have enough transmission to support it. In our industry, when we say security, we're talking about adequate transmission. When we say adequacy, we're talking about generation sufficiency, right? But there's another component, which is resilience. Or resilience is the systems that resilient that if you lose one generator or one transmission line, you will still be able to serve your load. Or something bad happens to it, it could recover quickly, right? So this is the main goal for the transmission operator or the transmission provider. But these things have to be done at a fair cost. Remember, I didn't say cheap. I said fair cost, right? Because you depend on generators for generation, you depend on end users, your customers to pay. So it has to be fair to everybody. And in all this, you have to make sure that the transmission system remains reliably intact at the same time. It's a tough job. Now, all these transformers, transmission lines, they have limits, they have rating, MBA rating that you don't operate to exceed them. In certain small situations, you can overload an equipment to certain percentage, but you quickly have to bring it down. And there are standards for all of that, 30-minute emergency rating and all that, or 15 minutes. You have to quickly bring it back. You don't stay in that status for a longer time. I already talked about ancillary services because you brought that question in, and so I'm gonna move here. Another thing to say is that we all get drowned in doomsday and power outages and we mix it together. But I want to make a claim here that not every power equipment outage must result in load shedding. When you operate the system, there are so many, as we speak, there are so many equipment that are out of service, but you still can deliver power to everywhere. And that is a very reliable system, right? And so not every power equipment outage must result in a load shedding or doomsday or blackout. Now, to do this, GridCo has to perform comprehensive studies on an annual basis. This is what we do in other parts of the world. The annual planning studies is a study that looks at 3 years ahead, 5 years ahead, 10 years ahead, and every year we move it one. There are other studies for real time, which is up to 2 years, operation studies. And even some that is up to 3 days, 2 days, 1 day, next day operation. So operational system operational analysis. They do so, all of us do that. In the US, we use the NERC standards. The main one is the TPL 001-5, which has prescription for how you should study it to make sure you achieve that goal that we talk about: safer, reliable, secure, resilient system. And in Ghana, these two standards and codes play a key role in whatever they study. But look at it, 2009, right? And this is 2008. So we talk about some of the things that we can do to make sure that these codes still address today's problems. But in the study must have or begin with a transparent stakeholder process, very robust one. It's only that you get complementary ideas to make the study better. If you just sit in your office and you think you are the best engineer, you can just sit there and do it, you're killing yourself. People have PhDs in little area, they can't even do the work by themselves because the way it's like medicine. If you operate on somebody, they die, it's evident to everyone. If you think you can solve the problem yourself because you are the only engineer in the company or whatever, please just humble yourself, okay? Share, coordinate with your peers and you become a better engineer, a better practitioner. That I can tell you as engineers, and practitioners. Never think you know it all. Okay, whoever you are, you don't know it all. Important of stakeholder process. Now, what do we expect from the studies? The studies should tell us what is the current problem that we are facing. And then, based on growth, load growth, as we saw 200, or was it 200 times increase for the last 10 years? And it's still growing. So in the future, do we have enough generation? Do we have enough transmission lines? Do we have enough criteria to address this problem or serve load? So current problems, future problems. Current problems, we can do something quickly about it. Either we have operating procedures and things that we can use to address. But the reason why you do the 3, 5, 10, so that it gives you enough time to do contracting, to build them. And so if you do this study and you come up with the problems or concerns of the system and you sit it down somewhere, you're hurting yourself. Now, those problems are not going away. They will keep coming. The same thing with our dooms, all right? Keeps coming, keeps coming, keeps coming. Most importantly, it's not good enough to say, oh, we need generation, we need transmission. The engineers must tell us exactly where we need those facilities. We need it in the Bolga pocket. We need it in the Sinyani area. We need this amount of generation in Tema area. We need to actually specify where these needs are, not just a blanket, oh, Ghana needs this, Ghana needs that, right? Yes, offer.
So when you say grid planning, you mean generation and transmission plan?
No, grid planning includes everything. Okay. Because in your grid planning, that's the study you perform. You have to come up with your generation dispatch scenario. Every grid planner or transmission planner will tell you the planning involves your assumptions. Your assumptions, you have generation assumptions, load assumptions, and others, right? And even the operating procedures, you have to model all of them to make sure they work. And it's only after that, that assumption, as I said, if you're looking for 10 years or 3 years from now, the load is going to grow from 4,000 to 5,000. I'm going to run my system so that I take care of 5,000 megawatt load growth, right? So it's the same thing, but the generation, the load, all that are components that go into the planning, the grid planning.
So the system operator is supposed to be generation plan. So
not the system operator, the grid planning function. We have two functions there, right? The transmission provider, in this case, in Ghana, Gridco has those functions. And I believe they have the planning department and operations department. Glenda, is that? Yeah. Yes. Okay. System planning, yeah.
Because there's a challenge. That's why I asked that question.
Okay, let's talk about it also more. Maybe I can share some ideas.
That's why I asked that question.
Yeah, thank you.
Yeah.
Yeah. I'll be available the next week or so, and we can take this further. Okay, so as an outcome from the studies or grid planning or system planning, I did mention that the planner has to come up with the problems and make recommendations. Then the report is created having all these in. That report must be taken seriously. Because you started with a stakeholder process, all your assumptions will be known to your stakeholders. The Ministry of Energy, CSOs, you call them what? CSOs, those organizations, civil society organizations, all of them will be part of it. It's not just the engineers. People have different ideas and different contributions. Involve all of them. But once that report comes out, then Gridco board needs to, through the executive, chief executive or managing director, they should approve it and send it to the board for review and approval. Once the board approves it, they make recommendation to the minister himself. And the minister, if he has, or she or he has questions, he or she talks with their, what do you call, he or she talks, make sure everything is clarified. But once we are certain, we have to make every effort to stick to that plan and implement it. And after that, she left. This report, all the approved projects should form the basis for capital project procurement, licensing, and by the Energy Commission. I think they license the license projects. So you see that everything comes from the top and it goes through the system. Everybody knows about it. Okay. What I can say, so we leave here, is that we depend on the grid code accurate standards to perform these things. Now, if those standards are old in every country, every year we are reviewing our standards, policies, before we can apply them. But this is sitting at 2008, 2009. I just read that RICO is now reviewing their master plan. So hopefully some of these things will be taken care of. By way of transmission, I also talk about system operations planning studies, which the real-time guys will do. It starts, if let's say tomorrow is an operating day, the real-time engineers will perform studies in preparation for tomorrow, right? And typically what it does is it gives them warning about system conditions for tomorrow, load forecast for tomorrow, different hours. It also aids better operational preparation. Then you have refinement in data. For instance, load forecast from last week and load forecast today for tomorrow. You can see a big difference. Sometimes in California, we have maybe 400 megawatt difference. So it's important to always keep your eye on the ball and prepare it. And then not only do you do the studies for the next day, you also look at the day after the next day and the day after, 3 days out. And you keep repeating every day, moving like a window of 3 days. Another thing system operator can do to help them, and we have implemented this. We call it frequency response margin. How many of you have heard about that? No? 8 to 10%. So what is it? What it is that for every generator, you have the Pmin and Pmax. And the goal is when you have frequency problems, you may have cascading system getting into other control areas like CEB or Ivory Coast, Benin, Togo, Benin, or Upper Volta. It goes around the whole system. And so what we do to address additional security, to address frequency, you leave about 6 to 8% of the generator Pmax. So if the Pmax is 100, you leave 10 megawatts at the top all the time. Unless, of course, here you need everything, right? And here we have 5740 and 4000 megawatt load. We shouldn't, but because of all the inherent restrictions, that even though you have 5,700 or 5,700 megawatts of generation installed, you still have problems serving the load, right? And these all go into what we just talked about location. So this helps a lot, this frequency response margin. It has helped us a lot. And most Germany also has it. Even South America, some of the control areas have them. And it's something maybe Ghana should also look at, that at all times, don't dispatch your units to the maximum, because when you have frequency problems, it's difficult to actually bring it down. Operate at 50 hertz. Another area is your procurement for operating reserve. It has to be procured economically so that you can reduce the cost. Another thing that we use to procure, as a guide to procure operating reserves, is what? The MOC, minimum operating requirement criteria. And what that is that In operation, you're looking at your single largest contingency in real time and say, if I lose that single largest contingency, means I drop energy capability, can I meet my load? And this single largest contingency element or contingent element could be generator, your largest generator in the system, right? I lose my most efficient generator, the largest in the system, or the largest transmission line or path, right? Is it possible for me to procure or serve my load? And that is why we need generation everywhere. So let's say you have a line from here to Pristia, Tema to Pristia, or to Kintampo, and I lose that line. And the only source of power is from south here going there. Can I serve the load there? No. These are some of the reasons why we need generation everywhere, so we can backfeed to serve the load. So every normal system operates under this MOC, your minimum operating requirement. So I'm operating, serving my load, all of a sudden I lose a transformer. Am I able to serve the load? It is on that basis that you procure the operating reserves in megawatt equivalent. So if I lose that generator, and let's say it's an Omasu generator is 250 megawatts, and so many bad things happen to the system, I'm going to make sure that I procure operating reserves to cover that. And it has to be not just megawatt, it has to be at an appropriate location, such that once I call that unit, it can serve that load. Another area that I think we do here, but I don't know to what extent, is coordination. Coordination among all the utility entities in terms of transmission outages, generator outages, voluntary electricity conservation, which we call demand response, needs to be coordinated among all of them. Gridco, ECG, NETCO, PURC, energy. Look, if we have the attitude and habit of bringing everybody on board, believe me, that alone will help us a lot. Because you may be sitting in the control room and you think you know it, but the generator has information you don't know or you don't have. Or ECG has the distribution level load information that you don't have. Somebody is building a mall. Obviously, it's going to increase your load when that mall goes into effect. And you sit in control, you won't know because you are not at that level. So for outages, system conditions, whatever, we need to make sure we coordinate among ourselves. And not just here, we also need to consider our friends in the West African Power Pool area, because we have direct link, couple with them through the interties. Anything bad happening there will propagate into our system. So again, if Gridco, ECG, NETCO, Enclave Power, these are the load serving entities. And they should all coordinate and also pursue voluntary electricity conservation at the customer end. Now, in California, and I think other parts of Europe, and during the time closer to Christmas, what happens? Everybody has lights on. Ghana, I don't know, but US is a big deal. We buy the Christmas lights you put on your house. Every house has it. Your kids will not even allow you if you don't put it on. And guess what? All of them add up for consumption. And so if you are sitting to the operating room, it usually happens a day after Thanksgiving in US. Because people are home, they have time to put it on. And the load just spikes after Thanksgiving. What we found out that if reducing energy usage during power system emergency conditions and even real-time peak load, when we need to do that sharp 1 hour, 5,000 or 6,000 megawatts, reducing that can aid grid reliability, preserve supply, and alleviate or completely prevent the occurrence of rotating blackouts that we call doomsday here. So conservation must be part of our solution. I bet there are some of you here, you left your office, your light is still on. And if I swear to it, I can say some of you even didn't turn off your air conditioning. It's a habit. It's something that we don't see, right? You pay it, but it doesn't come to us. We are humans. I've heard people, they iron and they forget to pull it off and it's sitting there. All those add up. How many millions of people here in Ghana? 40, 30? Let's say 40 million. Let's say 30% of us, which is, let's say half, 50, 20 million, have access to electricity and we don't turn it off when we don't need it. I'm not saying don't use it if you really need it. But once you're done, turn it off. These lights, they all add up. If you get 1 million homes and they have even 4 lights and you leave them on, they all add up. So that should also be part of our solution. I've already talked about coordinating and collaborating, but in this case, ahead of time, in advance, not just when things are happening and picking the phone and rushing around, but plan things, plan it well, and be in the job business of always working, planning, looking ahead, and observing your system. As cost-saving mechanisms, there are also non-transmission alternatives and great enhancing technologies. We call that GETS, right? GETS, these days, there are conductors that can resist high heat and have low sag. If you are planning, sag, they have mandated clearances that you need to meet, or even underpasses need to have a clearance. But GETS, great enhancing technologies are now with us. We use them a lot in California. I'll mention some of those conductors here. But non-transmission alternatives, as I mentioned, getting the load, getting the generation closer to your load actually alleviate you from spending lots of money building expensive transmission line. And we talked about batteries too, that they play a very key role when you are at your peak there. When solar is gone, that becomes a source of energy that you can inject into the system within milliseconds. So for the GETS, there are conductors like ACCC. Do we use something here? Or have we? Very good. What these do, I already said that it allows you, even where you have shorter towers, right? Because the low sag capability, it doesn't sag that much. Towers are expensive. Everything about our industry is very, very expensive. People don't know that. They think you just sit there and, get power, get transmission. It's very expensive. So any little thing that you can do to save cost, they all aggregatedly add up. And those are the things I would like, because we don't have all the money sitting there, let's look at them in simple terms. We don't have to get $1 trillion before we start doing something. And so ACCC is mainly aluminum conductor, a composite core, and it features a carbon fiber composite core. And then we have the traditional one, also ACSR, aluminum conductor, steel reinforced, but these have better performance than that, right? In fact, there are a graded one, which is ACSR based, but there's a gap, they put a gap in between. So that the heat is reduced. ACSS, aluminum conductor, still supported. This is widely used in for reconducting old transmission lines. Yeah. Cybersecurity. Our headache these days in the transmission system or distribution system, cybersecurity. I don't know how hands-on we are on that in this country, but I'll just say if we don't, we better be looking at it seriously, because physical and cybersecurity incidents or violations could potentially pose catastrophic impacts and imperil the Ghana electricity system in such a manner that it will lose its ability to operate and deliver to its mission. Right? In North America, it's mandated as part of the standards. Every year we perform studies. It also includes perimeter of physical cyber stuff, like substations have to be protected. Even some transformers have to be shielded so somebody can shoot into it. It happens all the time. So physical and cyber security is something, if we are not doing or not doing more of it, we should do that. As we are preoccupied with natural gas and generation and all the talk is there, somebody can take us out just like that. And it can come through computers. It can take you through computers and other stuff. I just proposed this. I never asked, I do presentations, not just in Ghana, other parts of the world. If I go there, I never tell people do what I'm doing. I just say, look at it. If there's something you can pick from there, please do that. If there's any help I can provide, I'm also available. But NERC, we use SIP 012-2. See, the -2 means revision 2. The next time you see it, maybe 3. We don't just design or develop a procedure or a standard and just go sleep. Luckily, I was part of the WEC, Western Electricity Coordinating Council Transmission Study Group. And this is where most of the studies stand. And then once we get to the point that is good, we file it with NERC. And it goes through intensive stakeholder process before it becomes a standard. Finally, let's go to the distribution system. Let's say distribution system is where our load is connected. It could be at a sub-transmission level. Some industries take them right from the sub-transmission, but end users, most of them are connected to the distribution system, the medium and low voltage systems. I just said load is classified or categorized into industrial load, commercial load. Industrial load, here we have a lot of mining load. And other industries, manufacturing industries. Commercial, hospitals, shopping malls, hotels, financial institutions, banks, they are commercials that it doesn't need explanation. Residential are homes. Now, notice that there have been so many big homes coming into for the last 10 years. I don't want to cite any particular location, but we all know. And what comes with them? Power, more consumption. And at the distribution level, what are we doing? Are we serving all these new mushrooms with the same old age network and equipment? Or have we seen distribution companies digging around and replacing existing 1970, 1980 conductors cables? I haven't seen them as much as I would like to see them. Not to say there is no work going on, but I think we are not the network is not keeping up with the growth. I think you all would agree with me. And why do I know that? Or how do I know that? Because I see a lot of doomsday, my power goes off. Why? It could be the system, the equipment is not holding. It could be the lines are overloaded, so they trip. If they trip, and unfortunately, as I studied the distribution system, it's mostly radial. Most of the distribution system here is radial. And if I'm hanging at the tail end and something happens ahead of me, means all of it is not dropped, right? We need to have tiebacks. So, and some of the load based on how they need to be serviced, we classify some of them as category or class 1, class 2. And the key ones are, I put a few here: hospitals, high security prisons, national security facilities. But in this place, we don't need to put all the money in. We can ask them to contribute using UPSs. You see, I have recommendations for the higher, bigger projects, but all these little ones, if you run, let's say a mall is not class 1, and if it doesn't open, nobody dies. But hospital, private hospital, they do surgeries in private hospitals and things like that. What about use some of your money by UPS, veritable power supply? But this must be led by GDCG and NETCO and Enclave Power if it has all those. Must be led by them. Can't just be like me. I don't know. How am I going to do it? So it must be led by them. Why do I also know that the distribution system is not keeping up to the load? It's because I know that in 2014, the load was 2,000, but 2024 is 4,000, and it's growing, right? And all this dramatic electric load increases have been supported by old staff. And what am I seeing? This has led to the constant routine distribution conductor and equipment overloads, tripping, and resulted in multiple electric service disruptions during the day with extended duration of service downtimes. Isn't that true? We are hung to the distribution system, and we see all of this. That tells us that the distribution is not holding. How do we assess the reliability of the distribution system or even the transmission system? SAIDI, system average interruption frequency index, system average interruption duration index. I bet we failed it all. So the problem is, how come we have sufficient generation and we have 4,000 megawatt load, and last year we all know the doomsday that we all experienced? Why? And this is why I explained to you the inherent problems. So you can build 1 million generation down south, all natural gas, you will have this problem. You can throw money at it, go buy it in the market, expensive, it won't solve the problem. Until we see that generation has been distributed all over the country at the strategic points. So the clue here is that procuring natural gas fuel is expensive, and yet it's not solving the problem. It's just draining our national coffers. So as I said, for you to know your customer is satisfied or the system is operating at a satisfactory level, we have indices that we use. And one of them, and several of them, but I put a few out here. SAIFI, I just mentioned, System Average Interruption Frequency Index, right? So if I have a SAIFI equals to 1.5, listen carefully, 1.5. It means on average, customers experience 1.5 service interruptions per year. Come on, Ghana, are we doing that? 1.5, one interruption per year. Where I am, they plan the system, they build the system, and I don't even see it in a year. I always switch my power, it's on. Right? So that's safety for you. System average interruption frequency. How frequent? In a day here. Even today, where I live now, it's like 4 times within an hour. So we missed all these indices that people use to classify the safety, reliability, and satisfaction of the system. SAIDI. So if you have SAIDI, these are all averages, right? It means 100, SAIDI equals to 100 means, usually SAIDI is in minutes because duration, not hours, it's minutes, not days, minutes. And systems are operating with these things. Other people are doing it. We can do it if we actually make a decision to build the plan that GridCo, the transmission provider, provides us. So in numbers, 100 minutes means the average customer experience 100 minutes outage per year. 100 minutes is like what? 1 hour, 40 minutes, the whole year. Okay, the lower the better, right? So if SAFE is equal to 1, we say it's considered a strong system. One interruption in a year. The average customers experience fewer than 1 outage if SAFE is 1. It's 1 or less. There is also the KD, which is customer average interruption duration, and then average service availability index. I bet our power system is failing all of these. The key thing I want to drive out here is that in distribution system, what's that? That's something I need to learn from. The question is, in Ghana, if they use this, what are they doing about it? If they don't use it, what do they have set for themselves? Anybody wants to take that one? What are we using? What indices have we set for ourselves online and others? But that's another story. But what hits me most is also on the distribution level. I have to be careful how I set this up. So I said normally in high voltage section you have 3 to 6%, normally 4% losses. Okay, but if you come to Ghana, we have anecdotally we have cases where we say distribution losses is 20, even 30%. Or is that not true? Yeah. So I wasn't making it up. 30% losses. So if I generate 100 megawatts, I only get to use 70. And what do you think is causing us? Cost, because we are paying 100 megawatts and we just use 70, right? So that is not nice. But again, the devil could be in the details. So I'm not blaming anybody, but let's go through what could be the possible avenues for the 30% distribution losses. Technical losses have to be the distribution system maximum maybe 6, 7, 8%. But look at the commercial losses. I'm not even worried about that one because that one we can do it to ourselves. Theft and other things we can, if we have the will, I think we can get that done within a month if we want to do it. Theft. And there are tools there to see everything going to somebody. Look, we need to have transparency in where every electron goes. And the tools are there. And it can be done within 3 months to 6 months. So I'm not worried about the theft and all that because we don't want to do it. That's why it's there. I don't see my system 30% losses and I just sit there over here and over. But look at street lighting. I understood that street lighting, the rate is set in the bills. If you look at your bill carefully, I think it's in there. And the question is, are we capturing the street lighting megawatts correctly? How are we measuring it? It could as well be that we are not covering or we are not capturing the street lighting values well. And that can be a reason for the 30%, right? So we need to go back and do some pilots and see how many megawatts, what is the consumption, the true and actual consumption from our street lights. I heard some good news this week. Our minister said they're going to put solar and a battery pack on street lights. He mentioned the quantity, but never mentioned the megawatts. Still. Okay. But knowing that information, knowing all that information also helps us in load forecasting and also what to set aside because we know the street lights will pick it up. Else what happens? We go to procure contracts. We are contracting for something that we already put in place and escalates the cost. See, these are simple things. Of course, the backbone projects and issues are there. But on the distribution side, there's a lot that we can do to minimize our harm and discomfort.
I think you are underrating theft. That's serious.
And that's why I said I'm not gonna get there, because I think anything I can point, anything there is either because we don't want to solve it, or but not because we cannot. Because if we want to do this, there are new, Schneider has all these tools that you don't even need to go to that location to see whether there is a meter or not. You sit in the control room, you see everything. How much power is going there, and nothing comes back as revenue. And you can cut that easily. Where I work, we can trip you, like my house in California. God being so good, I can pay my bills. But for those who can't pay, they won't come to you. They just open your breaker, that's it, remotely.
I think you're taking, what I consider the wrong attitude. I think the attitude should be, we have the tool.
We do.
So we must focus on.
As I said, I'm just bringing this about. My main concern for this 30% is let us look at what we are not capturing can do. Here, I think if we want to do it, most of you have the solution here. Theft, right? Theft, meter tampering. Come on, we're making it to ourselves. But here, I think there is honest, in terms of street lighting and the megawatt quantification, I think there is an honest effort that
The ease of the tool makes that effort that much.
I agree with you. What Dr. Boachi is saying is that he's very passionate about fighting that stuff. And I agree with you that the tools are there.
We're not aware.
Okay, and that's the main reason we are having these kind of presentations. So that if you are not aware, after the presentation, a day, a week, a year, or whenever you're ready, give me a call. You have my email at the top of the first slide. Prof, how can you help us find this or find that? Or ask somebody else. This is okay. But the tools are there. It's being used. It's not experimental. It's not something somebody is dreaming. We use them. And the question is, are you willing to do it? All right. So, so that's another thing. And on the transmission side, I also learned that, and we all know, I wish I could draw something there, where you place the meter to measure your power or energy coming into your system plays a very big role. On the high voltage transmission side, are you placing it at the 161 kV switch yard? Are you placing it at the high side of the generator step-up transformer, not slide number 3 or so? At the generator terminal, there is a transformer that connects the grid to the generator. And after the transformer, there is a short line or long line, depending on the connection to the grid. And it comes to the switching station or substation or a bus. Placing the way you place your meter also means a lot, because if you've noticed, most of every generating plant has an aux load or service load or station load. If you place it such that you are not apportioning the service load or station load to the generator, you will see some things like this. So you need to place your meters at the right locations. And I'm not proposing in this presentation one way or the other, but I say put it at the right location to capture exactly how much is coming to you. And that goes back to my thing to say transparency, every electron. That alone, that tool, if we're able to do it in 3-6 months, will save us a lot of money. I've seen it used. It gives you transparency. And again, I talk about a direct correlation with load forecast, right? When you do your studies, you are projecting the load, you're forecasting it, and you study based on that. And you say, I need to procure generation the next 5 years to set the load, expected load growth. But it so happened that your streetlights have taken some of them, but you don't need that. So when you are planning, you set those, you plan accordingly, taking into account those. And also in your bills, maybe the rate is not good enough. Now, I think this is where private sector comes in, right? So all I would like to say is for private sector, we need them to help us. So let me give you 4 main areas that we need private sector participation. I think time is running up so fast for us. We couldn't start early. First of all, I'm with the government and the sector saying we need independent bill collection to collect our bills for us. That is fine with me. If they can do a diligent, but when you are drawing that contract, that is where the problem is. Make sure it's transparent, it's clean, and the person is capable, the entity or company, capable of doing a clean job for you. If you mess up the contract, you mess up with the problem. Second, distributed renewable solar systems. It's incumbent upon the ECGs, NEDCOs, and private sector. But the ECGs and the low 7 entities, I put all of them in one, they should lead the way. They should lead the way so that people, they will facilitate all the distributed generation, whether on the rooftop, in other parts of the world, that's what they do. The low 7 entity is not removed from installation of these things. And in some cases, even the state governments give credits, even feed-in tariffs, all of that stuff. If you don't use the energy, you sell it back to the system. Another area that we don't have time to discuss so much, but restructuring. Quite frankly, I believe the low 7 entity needs to be restructured. Restructure to allow the private sector to own, operate, and maintain parts of the medium and low voltage distribution wires, as well as provide electric service to customers. This is the main domain for ECG NEDCO. And we can get into all the details, but I feel the way things have been, the money is not there. We should allow concessions for private sector to play in this space. The fourth one is that, let's say, Airport Hills or East Legon. Maybe there are people there as a community who would like to contribute and support the feeders that is going to their own area or Trazaco. Maybe they are capable, but are we reaching out to them as a community-based solution? What I want to recommend here is that the national energy policy that we have must provide opportunities for the public, the citizens, to invest in the distribution feeders serving their local areas. It makes them also feel like they get ownership. And there are so many ways to offsetting their investment. You know, they are not putting it for free, but at least it gives you the early capital to be able to do these projects. Yeah, we talk about street lights, and of course, I was recommending we put street lights on solar and battery, and the government, I think, has started all of that. Conservation, I couldn't say it more. We need to run it through people that they need to conserve energy because we don't have it. If we have it, it's at an expensive price or cost to us. So any little that we can effectively save helps the whole system. And GridCo, low 7 entities, PRC, they should all be part of this campaign. What are the key takeaways after all of this? I think there's been so many problem identifications. Recommended. So the main takeaway is that first and foremost, we should open the energy sector for dialogue, honest dialogue. Okay, I mean, we all want it to be better for us. Nobody is here to say you did wrong, you did that. We need to open up, okay, and so we can address our problems holistically. As a matter of crucial national agenda, I would say deliberate measures must be taken to stick to the plan. What plan? The GridCo study that informed us that we need to build a transmission line here. We need to build collector system here. We need to build solar plants in these locations. All those things, once they are approved and agreed upon and approved, we must make progress on them, no matter what. Because in the long run, it's going to help offset all the money that we are putting into one fuel. And so that is the government we must prioritize the funding and implementation of those projects that we all have approved. The GRIDCO board approved, the minister approved, everything. So we need to move on. Takeaway 2 is I just described that we need that tool that tells us and tracks every drop of electron from the generation station through the transmission, through distribution to my home meter. Okay, and there are so many benefits to that. I intentionally put this in here so for the benefit of those who would have copies, they can sit down and read it later. 3, we have hydro. A hydro to natural gas is about 2 to 1. I think when I checked, the hydro total is about close to 1,600, and the natural gas is 3,400, rough estimates. We need to augment all of that with solar photovoltaic, which is decentralized, and wind. At the National Interconnected Transmission System, which is the high voltage transmission system, as well as the distribution system and the end user locations everywhere in the country. Because we have data that says that there is enough, enough commercial scale of solar for solar energy. We also have the same information for wind. So what are we doing? We're never talking about rigorously pursuing that. Okay, we do have some solar. I think we have 20, 20, 40, and then 28.8 VRA, and another 55 from WID. Okay, but it's not enough. It's not enough. Okay, so we talked about the recommendation for privatization, 4 areas that I recommended. These are the same areas here, so don't need repetition. Another key thing that needs to happen is to expedite implementation of the wholesale electricity market. This has been, I think we are already done with the design. It's been championed by the Ghana Energy Commission. They even have a panel there with a chair. It's called the Electricity Market Oversight Panel. I think most of the CEOs of the energy sector are on it. But it's been sitting there. Now, what is the electricity market going to do for us? Properly designed electricity market determines how best to meet the system reliability needs and also provide immediate fair pricing relief to ratepayers. And so we have to find ways to quickly or expedite that implementation. We talked about the heat rate curves. It also fits into the getting the right fair prices so that we have immediate cost relief for ratepayers, which is the customers, as well as making operations easier and reliable for the operator. 6, we already talked about reviewing the existing standards and codes and operating procedure to make sure indeed they address current problems, not 2008, 2009. And the good thing there is that I've heard GRIDCO is now seriously reviewing their master plan, which probably includes reviewing these. Is that Linda? Energy Commission, okay. And use it, GRIDCO uses it. Actually, that's why, because it has the Energy Commission code, yeah. We also talk about non-transmission alternatives, which dwells heavily on solar and wind, which I think we should do, and also gets great enhanced enhancing technologies like efficient conductors. They have also talked about physical and cyber security. I don't need to get into all of that again, but it's a place that we should also pay attention, because the cost of rebuilding and bringing essential and damaged power equipment back in service due to physical and cyber security incidents could be very expensive and comes with a long lead time. So if they take us down, power is not coming back anytime soon, and especially when we don't have the money also. We need to do close coordination among the Ministry of Energy, Energy Commission, PRC, end users, advocacy groups like the civil society organizations. ASAP, I think, is one of them. Bring all of them on board, the better. And ECOWAS WAP, West Africa Power Pool, we need to coordinate with them seriously. Now, let me say this. This is just not power thing, right? Usually, you want to give confidence and credibility to your system and people who are your stakeholders, investors alike, they are stakeholders. So it's a good practice for the executives to always defer communication, immediate communication stuff to their PRO. They are well trained for those kind of jobs. What does that do for you? What it does for you is that if your PRO or communications team go out there and speak, then you as the director or chief executive, you have a way of clarifying it without, and you bring more confidence to the system. But if something happens and you, the top guy, speaks and you misspeak, who is going to correct it? You start. So it's a soft skill, but it's very, very important, because we are all around the world. And today, the world is a little village, as Hillary Clinton said, right? Everybody is connected. If you misspoke and he says, oh, Ghana, we don't have the power and the solar, and natural gas is not there. Investors look back. There are certain times that I want to bring some people here to help us do work, and they say, oh, I don't want to go to Ghana. And they'll cite some of these things to you. So whatever we say has meaning somewhere. So we should be very careful when we pick the mic on TV or radio and talking. Okay. There are so many things that goes on in American energy system and other banks and stuff. You wouldn't hear it. Look, Lehman Brothers went out of business a day before even the workers knew that they were going to job. They went, it was closed. It's not everything that you throw out there. Okay. It's best for you to sit down, plan your solution strategy than to go just talk out there. And the final, for entertaining me here, I have something for the media and the civil society organizations. They have an obligation to vet and empanel credible power and energy sector experts, comprising practitioners, technocrats, researchers, policymakers, and allied personnel who have direct and hands-on knowledge about the industry to constructively dialogue, diagnose, and prescribe good solutions to address the energy sector issues. It's incumbent upon them, the media. You don't just give a mic to anybody claiming to be an expert and they just say whatever they want. This will bring focus. If they do this and panel the real practitioners and knowledge-based people, it will bring focus to real and informed concerns or problems. It will aid better planning, avoid panic, and provide certainty in the energy sector and boost the end user and investor confidence. I thank you for enduring me and indulging me. Thank you so much.
Here we can do it better for you. Yeah, thank you very much, Dr. Mensah-Bonsu, for this comprehensive delivery. Now it's time for questions. But it's almost 8 o'clock. So I want to propose that we take only 4 questions for those here, and then 5 for those who are online. Okay, 5.
2, no, 5, so 3 here and then 2 there.
Okay, so those who will ask questions here, can I see your hands? So we already have 4. But my seniors, you have asked plenty questions already.
Mine will be very short.
Can we? Because I know you have it. So
Let me start with Prof, thank you very much for the presentation. My question is on the location of sources of generation in all parts of Ghana. I believe in benchmarking, and in your presentation, you kept mentioning California, Australia. I believe when Akosombo Dam was built, the intention was first to industrialize Ghana. And at that point, the heaviest load in Ghana was in the south. So if you take Accra, Tema, Kumasi, the remaining loads in Ghana are more of domestic. So if you cite generation in, say, Tamale, Bonga, you end up wheeling the power generated there to the south, because this is where the load is. My question is, in benchmarking, what is the average distance for wheeling? I am in the transmission sector, so that we know citing generation should be within a certain distance. Yeah, thank you.
Let's take the second. Nothing for me, I don't have. But let me answer quickly. So I'll be brief. Dr. Kwame Nkrumah Osagyefo did so much for this country. That was 1960. The load that you said correctly, rightly, was here, mostly Tema. 1960 to today, how many years? Ghana has grown. What have we done? We've done some, but certainly not enough. That's why we are seeing these things. Today, if you go to Kumasi, forget about manufacturing and industrial load. Residential load alone, those in ECG can tell me the load is grown, maybe more than Asante regional load, Kumasi, Bepai, Obuasi, so those major cities. The load alone is probably more than when Kwame Nkrumah built that generator for us. All I'm saying is the dynamic is fluid. And we need to meet the load where they are. In terms of distance, as electrical engineer, I talk about electrical distance using line constants, impedance, right? The study engineers can do that better than us. I'm standing here. So whatever it is, we know that the load is not now concentrated only in Tema and Akosombo, right? The load is everywhere. And even if you are not building huge 250 megawatt, 360 megawatts, we can build 5 megawatts, 10 megawatts, 2 megawatts, 1 megawatt, kilowatts. That is what I'm talking about. And that gets the generation everywhere in the country. We cannot continue to operate this system, especially the natural gas alone. That's the emphasis. We need to augment it with other sources of fuel. Thank you.
Hello. I think the point has been well made to the extent that given the problems that we have right now with the conventional systems, the high cost of fuel, the cost of electricity itself is so high, etc. And the way forward is to go solar, renewables, and things like that.
As part of the solution.
As part of the solution. But the important thing I want to stress here is that we cannot do this solar or the renewables in isolation. In fact, it has to go in tandem with the conventional systems. And very, very important is about the upgrade in terms of capacity and stability of the transmission network because of the intermittent nature of.
Now you have to cut you off because you are making suggestions instead of asking questions.
So what he's saying is he's in agreement with what about.
So Chief,
you talk about issue of
The fuel source.
the generation. And actually, a lot of the road has been residential. Uniquely positioned for the residential solar. We happen to have all over the country. Unfortunately, it's financing. That is the issue. So can we come up with some, innovative way financing to actually make solar the real, because I believe that's probably the fastest way to move forward. But financing is a bit off.
Yes. You will know that in my presentation, I gave some hints, right? I also talk about the low 7 entities need to be restructured. I also talk about the low 7 entities need to lead the way for all this. If we're going to do rooftop, they shouldn't remove themselves from it. But remember, I made those 3 points. And that I think that's where our solutions will come from.
I, as a home,
Yes.
I need a loan to be able to implement some of this.
I think you didn't hear me. I said the solution will come from the low 7 entity being part of it, okay, and leading the way. It's been done elsewhere. There are even, if you look at it as, let me speak English to you. Let me speak English to you. So if you consider that we put in a lot of money in natural gas, it even makes sense for the government to give incentives, cash incentives, to offset that. My home, I have solar. They gave me, I don't want to say, but I got $10,000 back through my taxes. Okay, but there are places even today in US, and you say I make reference to US. I know that some of them work there. If you buy a new fridge, they give you a rebate. The utility company will bring you a rebate. And why are they doing that? Because it helps the system. The new refrigerators and microwave ovens and stuff consume less electricity. So instead of them going to procure expensive energy to serve your electricity guzzler, they say, we'll give you some money to put in efficient appliances, and it serves as the purpose too.
How does you go to the bank and say, give me money so I can
No, you don't go to the bank. I think I said that low 7 entities, the new ECG or the current ECGs, they will have to be part of the solution. And at the right point, we could engage on how they do that.
My question is simple. Where does nuclear play in all this distribution? Okay, you gave a number of options for generation, right? But I didn't hear you mentioning nuclear. You did solar, gas, hydro, but where is nuclear?
Okay. You never also heard me say, don't do gas. I saw don't do nuclear. You never heard me say that. For me, everything must be considered in a balanced portfolio. We can assess nuclear, and I think it's an option, and it's a good option. But I want something now. Now we are bleeding. We are right at the battlefront. This is not where we check into a hotel. We need a bandage to put. So
part of the presentation and say the long term. Yes,
we'll do that next time.
Yeah, I think we now have to move to the online.
Yes.
So I think Enoch Ajipong is the one who started. So we should listen to him and then. So Enoch, can you speak? Unmute yourself and ask your question.
Right. Thank you very much. If you can hear me, please confirm.
Yes, we can hear you. Go ahead.
Right, thanks. So I personally have had a good appreciation of the presentation, and having been someone who's worked in the renewable energy landscape, also on the policy front, and then also in infrastructure with the bulk supply point at Pokwase, and my work in the past with Millennium Development Authority, looking at the tariff plan, the capacity scan of the sector, and bringing various stakeholders together to achieve that which we want to achieve. I find the presentation very, very impactful. I think someone had mentioned the aspect about nuclear, which I had listed, so I'll just take it off. But in terms of the renewable energy portfolio that, Doc, you are talking about, I'm just also wondering the place of mini hydro. And I know you're looking at the fact that we're bleeding now and things can come upstream and should come upstream. And so I'm just looking at what you would also have as suggestions or ideas around mini hydro especially, and if you can also share your experiences around net metering, because I know that the renewable energy portfolio standards that California has is practically one of the key things, and you talked about a bit of the incentives and the stakeholder involvement all across. I know that when we talk about the battery energy storage systems as well, there's always that issue we have in Ghana where the port authorities and the GRA seem to want to have huge duties and expenses on these battery systems. So it makes it very difficult for people to even want to bring them in, right? So it'll be good to just understand if you have any thoughts and ideas. I know you're saying you don't profess all the knowledge and wisdom, which is very clear. We all understand, but it's good to understand if you have any practical insights as to dealing with the issue of revenue generation for government through the ports by having these costly duties that are imposed on batteries, if we are looking at it as one key solution. The next 2 points I have, which I'll close out with, is the issue of the apps, as you mentioned, that you're able to see the critical information about the system
Let me help you out. Let me help you out. You have my email on the list. Can you hear me, sir? Yeah,
yes, I can.
Get in touch with me. And I think we could address your questions comprehensively offline. But I will say this, that you brought up so many things out there, right? Mini hydros. Now, by the way, yesterday, Business and Financial Times carried my article, a feature article on what some of the things that we talked about here. It was the whole 4 pages they devoted to it. If you haven't seen it, please get a copy of the 21st July edition of the Business and Financial Times, Ghana. It's on page 30 all the way to 33. They devoted that to. It has a lot of in there. Now on the renewable energy, I intentionally didn't want to get into all the tasks. We have mini hydros, which is the definition is up to 30 megawatts. Okay, and I can explain why 30 megawatts. Any hydro that includes a major dam and displaces is not considered as renewable. The definition has been for up to 30 megawatts. For this present in there, you agree with that? In the article that I wrote and came up yesterday, I brought a small hydros in there. However, I also made a caveat that due to Galamsey, I don't think our water body is right now for mini hydros. If you can have clean water flowing nicely, turbidity and meaning the mud stuff, then I want practical solutions. It's not just because okay. And that is why I didn't emphasize, with the interest of time, I didn't want to emphasize all of that. So you talk about net metering. right? I was luckily, was it 2018 or so? I was part of a team here at PRC, and I reviewed the Renewable Energy Code. The recommendations that I put on there, but the consensus was that maybe it didn't rise to the top. That's why I'll leave it. I think in my discussion, I said we need to go back and review things that we have done in the past and see whether they are helping us problems today. We need to do the net metering, meaning if somebody puts rooftop generation, PV solar, a solar PV photovoltaic on his roof, and I leave home, I go to work, 8 o'clock, I come back at 5 o'clock, meaning I'm not consuming that power. I must get reimbursed for that through the net metering. And in principle, they'll do that. But how do I get paid? Is it 1-for-1 at the wholesale price or the retail price? Those are the things we can get into when we decide to go back and look at the code. That's all I can say about it. But for the rest, I'm happy to, engage and learn from you also.
Right. Look, just a point of information, the net metering we have in Ghana currently is not even one that allows payment in cash. It's just netted off in terms of the energy consumed. And so that's definitely something worth looking at. But I think finally, it would also be helpful if you can speak a little bit more.
I'm familiar with it. It's 1-for-1. Yeah.
Yes. If you can speak about how ISO is not necessarily a for-profit organization.
We have to end with you now.
Yes, I'm just going off. I'm just going off now.
In line, there's some work done on net metering by PURC, USAID. We can provide some information to you on that. Let's ask Engineer Buffalo to come in. And please, when you are coming in, leave out your photos so that the bandwidth we are not disturbed with your internet connection.
We're losing your voice every now and then.
Right, noted.
Engineer Buffalo, it's your turn now. Kindly unmute yourself and then.
Show your face briefly so we can all see.
The presenter wants to see your face briefly, so just show your face briefly and then you can turn off the video.
Oh, that's one to see, right?
I think it's gone. I think.
Yeah, go ahead.
You
see my face? Yeah, have you seen my face now?
Now you can turn it off. Now you can turn it off. Thank you.
Okay. I enjoyed the presentation. You say? Can I speak now?
You can turn the video off now, sir.
I'll put it off.
Go ahead, speak. Please.
Yeah, I enjoyed the presentation, but I expected some comparative analysis because our problem, basically, apart from the losses, is also investment, the capital. So these new ideas you have brought, BESS, NTA, all of them will cost some money. The first place, where are we going to get the money from? Second, we were expecting the comparative advantage of going BESS, or for the peak load, is it going to bring our tariffs down a little bit, or is it rather going to shoot it up? Because the little knowledge I have about storage batteries is that they tend to be expensive, and in terms of peak load tariff, it tends to push it up. Now, we are in a situation in Ghana where our tariffs are a burden on most consumers. So if we are suggesting something which will push the tariff up, then I'm afraid, but since you didn't give us any comparative analysis to show how much you could gain or lose by going BESS or using the NTA, that's the non-transmission authorities. So if you can elaborate a little bit on it, and if you need some time to do this thing. My last comment is that I think you will need a little bit as an academician to talk to some of the institutions, because some of the things you raised, I think Greco, for instance, should be a little bit ahead of some of the issues you raised. ECG, because of the losses, are uncommon. Thank you.
Yeah, thank you so much. I don't know at what point you join us in the meeting,
Oh, I was
but
only
I
15
did
minutes
mention
late.
so many options. Okay, so I talked about so many things that are part of the solution options. Okay, and where they solve the problem. I use, for instance, the load profile to tell you where BESS, battery energy storage systems, can be effective within a short 1 hour, 5,000 megawatt ramp. Okay, along those lines, I talk about the fact that unfortunately our industry costs a lot of money. Anything you want to do in the power system, whether it's a transformer, even if you can get it, especially these days, costs a lot of money. But what we can do is to scale that cost gradually into small solutions as we wait for the bigger ones. Now, solar, I don't think you're doubting me that solar is a good option. In fact, an excellent option to help diversify our generation portfolio in a very fast manner, because they are easy to implement and quick to bring online, versus building maybe a 500 megawatt generator and all the stuff that go with it, or even building a one transformer or transmission line. Just recently, Greenco made a report that they are building a 122-kilometer double circuit transmission line to connect to Ivory Coast. And that 122 kilometers cost him 181 million US dollars. In fact, they coded it in euros, which was 151 or so, $158 million. So our industry is not cheap. And that is why throughout my presentations, I try to hint on where and how and our vision to reduce cost. Okay. So if you're gonna want something that is cheap, it's not this industry. But even with that, we have to make sure that whatever we buy, as we say in Ghana, value for money. Whether be in contracts, procurement, or everything, we should know that everything ends up with the user. As you said, the bills are high. We know because we're procuring, by the way, I never said we should stop natural gas or put it at bay. I'm saying just expand the portfolio to include these things. We need a natural gas plants, but the location that they are now, it's not helping us. And that is why for so many years, from President Rawlings' time, President Kufuor, all of that, we always talk about problems in the energy sector. I have my email also there, and I'm willing and ready to talk with you on the phone and meet with you. If you are here in Ghana, I'll be here for the next couple of weeks. And in the interest of time, I think also get a copy of the Business and Financial Times paper that they have a feature article there that I wrote, and then we can talk. But I hope that helps.
Okay, we'll look at it.
Thank you, Engineer Bafo. So we'll take two more questions, one from Engineer Frank Kochri, and then the next one from Samuel Safo. So, Frank Kochri, please unmute yourself. And as for you, I think the speaker knows you already, so you can you can go ahead and start talking without the video.
Good to see you.
Thank you, and good to hear from you, Chris. Good presentation. Thank you, Mr. Modi. Mine is on one of the earlier slides, and I think it's on the renewable energy, and the slide was saying that the solution to improving reliability is with the introduction of the renewable energy. And I thought, yes, I mean, the future is renewable energy. And so all of us, our focus and the effort is to tweak the system and make it possible to integrate renewables. That notwithstanding, I thought renewables typically reduce your reliability, due to the intermittency and their variability. They don't fundamentally help your reliability. I remember reading an article from Germany where in less than 5 seconds, the generation from renewables reduced by 19 gig. And then it came back about double of that within a few seconds. And typically, that is why when you install a lot of renewable energies, you need the conventional plants actually to regulate their intermittency. So that's what I wanted clarity on. Probably, I mean, as I said earlier, renewables is the future, and so we need to move on. But we need to let people know the challenges that they also bring along. One of the things we have not talked about is the high harmonic impression that comes with the renewables because of the heavy use of inverters and pulse width switching. Yes. The other challenge in Ghana is that our peak load happens in the night. We are not yet like the West, where their peak demand happens in the day. And most of our renewable potential is solar, which is zero in the night when our peak happens. And so the challenge of meeting our peak would remain, even though you put a lot of renewables. And so we need to put all that in perspective. So that's what I thought I would throw in. But Chris, it's good to hear you. Thank you.
Thank you. Let me take the last question. I think I explained it in detail with respect to the peak hour in relation to solar, right? And I linked it with poor hydro condition versus giving relief to the natural gas plants. Meaning, as we all know, we tend to have scarce natural gas availability in the country. So the little that we have, if solar is giving us energy during the day, we could hold off. It meaning it's going to give a relief, going to take the power burden or the energy burden from the natural gas plants. Any relief is good than nothing. And I never wanted to suggest that nighttime solar is there. And I was very conversant with that belief. And so I specifically addressed that when I talked about the peaking. And all I said is that all these proposals do not exclude natural gas or conventional units, hydro, and natural gas plants. But you have solar to come in during the day, and you can rest the natural gas units at a certain level, put them at a lower operating level. And when solar is dying and the peak is coming, you have enough room in your generation capacity in terms of natural gas to bring it up to serve the load. We saw you working up, you are an operations manager. I know that. But you bear with me that if you are a control system operator or system operations engineer, and you have between 6 and 7, a sharp ramp of 6,000 megawatt, and all your natural gas units are at their P max, tell me, how do you operate that grid? As opposed to if during the day you have taken some of the generation burden or load service burden from those units and operate them at a lower operating level, That way, when you come into the evening, 6 p.m., 7 when the solar is going down, you have enough room on your natural gas plants to actually move faster than when they are already at the peak. Already, I did mention we need to consider frequency response margins, right? And it's for those reasons that I was putting that in addition to also resolving your frequency issues for you. Truly, renewable energy has, you talked about harmonics, and one of my areas was power quality, okay? Inverters and converters, they all introduced that. But the technology has advanced so much that now we can even build 500, 6,000 megawatt solar PV and even regulate it as if it's a natural conventional unit. Most of the solar units in the US and other places, we're able to regulate them in terms of power factor or megawatt or frequency. So that is not a problem now, maybe in the past, but that technology has advanced so much. And you and I'll come to the office sometime this week and we can sit and talk about it more. If it's not working, believe me, other utility companies elsewhere would not be, they would have dumped it now, but believe me, they are now doing even more. So it depends on what technology you are familiar with now versus what is actually being used. Yeah. Thank you. I hope that answers your question.
Okay, thank you very much, Frank. We will take the last question from Samuel Safo. Samuel, please unmute and ask your question.
Okay, thank you very much, Prof, for your presentation. But please, Prof, I want to ask this question. From the flyer, I could see that there's a practitioner's perspective. And I want to ask, what is actually hindering us as a country that we cannot pursue vigorously some of these solutions? Because in your presentation, you repeatedly said that there are some of them, if only we are ready, and then as a country to actually implement them, we can do it. So what actually is hindering us? Is it politics? Is it finance? Or what at all that we cannot pursue some of these solutions to actually relieve the burden on us?
Peter? Yeah, I think, Simon, you have a very good question there. What is actually preventing us from doing this? Is it financial? I don't think so. Because if you put how much we spend on emergency procurement of fuel, and you think about national agenda long term, and you put even 1% of that somewhere, in the next 5 years, you'll be able to save enough money to do that, those projects, some of the projects, maybe not all, but at least you make good progress. But in terms of politics, I'm not the one to speak to it. Mine as a practitioner is to illuminate on what is possible. I've already given avenues of funding, and then also to emphasize, so my response to your question is that as a nation, we have to also look at strategic investment. Strategic investment, and in the energy sector in particular, because we all know that we cannot be the best economy, the best country, inviting investors to come and build factories and that with this system that we have now. We are just money into fuel procurement, and underlying issues, as I have identified and clarified here, still remain. Thank you so much for your question.
Thank you very much, Samuel. I think that's the last question. So again, let's give our professor presenter a round of applause. Before we end, I just want to say that Dr. Mensah-Bonsu has given us a lot of information on the challenges and has proposed some solutions. But I want to, in addressing the last questioner's question to say that it's not all doom and gloom. He spoke about diversifying location, and I know that currently there's 50 megawatts solar that is being installed at Yeti with the support of Power Authority. So that helps in yes. Also about the FRM setup, I think our governance have been set so that they are not always so there is some margin for regulation.
It'd be good to know what margin is there.
I think it's about that 10%, but we can verify. And I also want to assure you that in terms of coordination, Ghana has what we call the PPTC, the Power Planning Technical Committee, made up of all the generators, the grid co, Heavy Energy Commission, the distributors, and all that. So there is some coordination, but maybe we can improve upon this by also talking to WAP in that regard. Then you spoke about cyber security and physical security, which GridCo takes very, very seriously at all these substations. I'm no more there, but I was part of a team that supported them to upgrade their skills in terms of cyber security with a US agency and USAID, and I think they are not doing badly. And last but not the least, with the Ghana wholesale electricity market, they've made quite some progress over the last 3 years. They have a roadmap that they've drawn. They have a ministerial launch of some working committees. What is lacking now is funding to really implement some of those things. So we just want to assure you that some steps are being taken. It may be slow, but the discussion today will help us also improve upon the momentum with which we are addressing all these things. So on that note, it's about 8:30. I want to thank all of you for being patient and listening to us. And I will now hand over to the chairman of the electrical division. Thank you.
Thank you very much, Engineer Mode. Shall we please give him an applause and then an applause also for our speaker? We had to organize this within a very short window, but I would say that it's been quite good and useful having Prof speak to us, and also for the audience. I need to acknowledge some people who joined us, because I think that we've actually been fortunate to have many of our seniors and industry players joining us today. So Engineer Dr. Kwame Boakye, our former president, we are grateful. Engineer Dr. Ajay, past president, we are grateful he left us. Engineer Andrew Totoba, for also a past president. We acknowledge your presence and are very grateful for you joining us. Our president-elect, the first, no, not the first, second, our president-elect, Sophia Tijani, who also joined us in this session. We are so grateful for having him. Yes. We had about 99 of 140 people at a certain stage. So, and then we have those who are here in person with us. Our great cool people. I see a Bismarck, Linda, Wafa. We are grateful for having all of you join us, and all those who have been able to join us this evening. Just the last comment on the financing that he said about a couple of weeks ago, we had an invitation from here to join EcoBank for a launch of what they said EcoBank Goes Green. And actually that financing, what came up, EcoBank has some funding from this climate action facility. where now they are giving loans. I may be advertising for them, but I think that as engineers, we must be at the forefront of doing home solar. I've had solar for many years, and I think that if you're an engineer, electrical, and you don't have solar in your home, you have to change. You have to make sure you have solar in your home. EcoBank said the facility is at 14% interest. You know, like our banks are giving 25% trading, but because they had that money from the climate action facility, they are giving the loan at 14%, and I think it's for 14 years or something that you pay over 14 years. So it's good. It's something that practically we can all use. And so as engineers, I would recommend that try and access that facility and get solar on your home. You cannot have an excuse for not having solar if you are an electrical engineer. Yes, I'll get a contact when we went there. And we actually planning with them to have a session, especially for us, because we must be at the forefront of using that to expand solar in Ghana. So we'll try and arrange that so that they come here and then have a session for us, as engineers. So thank you very much, all of you, for joining us. We are grateful. We have some few refreshments at the back. As you go out, you can pick that. So thank you so much once again. We'll ask Engineer Linda to give us the closing prayer she will have. I will now say something to give us closing prayer.
Thank you, Mr. Roberts. Shall we pray? Heavenly Father, we thank you so much for giving us the grace, the strength, and the opportunity to participate in this knowledge sharing. We just pray for grace as a nation to be able to do, oh God, the right things that will improve the sector. We thank you for the life of the presenter. We pray for strength for him, that he continue to impact his experience and help support the industry. And we pray for guidance as we go back home and ask that continue to help us to improve in all areas of our lives. In Jesus' name we pray. Amen.
Amen. Thank you very much. Yes, thank you so much for coming. And thank you, our operator, also for staying with us. Yes. Thank you. Sorry that